this video, we're going to discuss about the domain and range. A function is a mathematical object used to represent a special kind of the relationship between the two sets of the objects. For example, right now, you want to mapping the set A with the set B. A function actually is a rule that you want to assign each of the element of A inside the A here to a unique element in the set B. So here, S, which is the element of A, is what we call as an independent variable. Why? It depends on the value of S, so we call it as a dependent variables. Set A is what we call as a domain of the functions, and this is a notation for you to put the domain of a function here. And then the set B is what we call as a codomain. And then for each of the S in the domain of F, the value of Y equal to the F under the function of F here is what we call as an image of S under the F. The set of all the images F is what we call as a range of F, and we'll put the notation in this way. There's one thing that you have to take note here is range of F actually is a subset of the codomain. So range of F might not be all the codomain B here. So you might question, what is the difference between the codomain and range? So I'm going to using the example here to illustrate to you what is the difference between the codomain and range here. So before that, codomain actually is something like the potential outputs of a functions. Then range actually is the actual output of a functions. So let's say for example right now, you have the set A and B. So A now is what we call as a domain, and B right now is what we call as a codomain. Now we want to mapping the set A with the B for the function of F here. If you're looking at the output of the function of F, it's only involve C, F, and G. So therefore, right now the range is only C, F, and G. Then later on, if I using another example to show it to you, for example, right now I give you the functions fs equal to 2x. And then the domain and codomain right now is all the integers. If you're looking at the output, if you try to map these integers inside the domain here, you will find that actually the output is only the even integers. That's why the range right now is the even integers here. Even though the codomain is the integers, but the range is only the even integers. So that's why just now I put the note over there. Sorry about this one. So just now I will put the notation over there that range of F is only the subset of the codomains. So range of F is not necessarily have to be equal to the codomain here. A functions can be defined by a different form here. It can be defined by a table, a graph, a mathematical formula here. So when defining a functions, the domain should also be stated clearly for each of the case. So now I'm going to show it to you the example that if let's say I give you a functions, how are you going to determine the domain and also the range of the function here? So for example, right now, I give it to you, the function is the exponential. For example, right now, the first example I give it to you, let's say now the function that fs I want to give it to you is the exponential of s. And then, how are we going to determine the domain of, and then also the range of the functions? So, we know that fs actually is defined for all the real numbers. Therefore, in this case, we can say that the domain of f is equal to all real numbers. And then how we're going to determine the range is if you're looking at the graph of the exponential x, let's say now, if you're looking at this, the graph here, we can see that actually, if your s is decreased without limits, mean approach to the negative infinity, your function right now is approach to 0. It just approach to 0, is not equal to 0 here. And then another thing is, if you're looking at, if your s right now is increased without limits, so you will see that your function right now also be increased without limits here. So with these reasons, so now we can say that the range of the f will be equal to the all real positive real numbers here. So we can put the notation as r positive like this way, or you can also put like the interval form. Remember, we're not including the 0, so we have to put the interval, the brackets like this way to show that we not include the 0. So you can use either way for you to show. If the question didn't specify any way for you to show the range, you can put the answer either in this way or in this way also is fine. Okay, now I'm going to show it to you. Another example, how are you going to determine the domain and also the range of a functions? For example, right now I give you the second example. I give you the function right now is gs equal to the square root of x. Okay, so how are we going to determine the domains? As we know that gs actually is defined for the real number such that actually will give it to you as which is greater or equal to 0. We know that square root to any negative value is going to give it to you a complex number. But now we're going to consider the real case, so we have to know that the s that we need to consider is only the positive, which is the s which is greater or equal to 0 here. So in other words, now you can put the answer for the domain of this G is equal to not the all real numbers. How are we going to put the notation, which is R positive, but R positive is only refer to the positive real numbers here. But now we need to including the 0, so you have to put union the set of 0 like this way. Or you can put the way like this way. Now we want to include the 0, so you have to put a bracket like this way. So 0 to infinity. Or you can put into the form like this way as well. So for the set of s, which is the s is greater or equal to 0. Okay, now how are we going to find the range of the functions of this function here? So for the range, how are we going to determine? If you're looking at when the s is equal to 0, we found that actually the function right now would be equal to 0. And then another thing we can looking at is when the s increase without limits, the function of g increase without limits also. So in this case, we can say that the range of the function of g is equal to all positive real number, including union the set of 0 here. Then it's also the same thing, you can put either way. You don't also have to give all of this, but I just show it to you what is the notation you can put if you want to give the answer either for the domain and also the range. So if you want to put in this way, or this way, it doesn't really matter. So these are the simple functions I can give it to you. Okay, how are you going to determine the domain and also the range?